Hello everyone, welcome to the Doubtlet. So in this tutorial video, we are gonna discuss the concept of how to find the volume of a parallelopiped. So parallelopiped is a three-dimensional cubic structure and whose edges are given as a vector. So this is A edge, this is B vector and this is C vector. And one thing that we have to remember, these all the edges are coincident, means these are adjacent edges. So the formula will be valid when all the given edges are adjacent. So we need to find the volume of this structure, and this is in the three-dimensional plane. So here x, y and z, all the three axes are used. So to find the volume, we will use the formula that we need to find the dot product of A vector with the vector obtained by cross product of B and C vector. We can also write this as B dot C vector cross A vector, or we can also write this as C dot B vector cross A vector. So this product will work in the rotation. So suppose this is A, this is B and this is C. So we need to find the dot with the cross product of this clockwise orientation. So this is how this will work. We can also write this as box product of A vector, B vector and C vector, and we can also write this as BCA and CAB, means box product of B vector, C vector and A vector, or box product of C vector, A vector and B vector. And what does the box product means? So suppose A vector is given as A1, A2, A3 and B vector is given as B1, B2, B3 and C vector is given as C1, C2, C3. So one method is, first of all you will find the cross product of this B and C and then we will obtain a vector. Then we have to perform the dot product of the vector obtained by B cross C with A vector. So this is the first method. But if you want to calculate it directly, then you have to find the box product, means determinant. So A1, A2, A3, B1, B2, B3, C1, C2 and C3. So we have to find the determinant of the vectors, and if you can use BCA also, so B1, B2, B3 will be in the first row. So you can interchange the rows also. And the volume is a positive quantity, so we have to obtain the magnitude. So we will consider the magnitude of all the results, whether it is the dot product or cross product. So this is how the volume of parallelopiped can be found out. So based on this concept, we will solve this example and we will learn how we can obtain the volume of parallelopiped if the edges vectors are given. So adjacent edges vectors are given. So we can find out the volume by this method, A vector dot B cross C vector. We will try to solve it by both the methods. So first of all, what we will do, we will find the B cross C. So B cross C is I, J, K. B vector is 1, minus 1, 1. It is 2, 1, 2, minus 1. So if we will solve this, we will get I cap minus 1, 1, 2, minus 1, minus J cap. It will become 1, 1, 1 and minus 1 plus K cap 1, minus 1, 1 and 2. So if we will solve this, this will become 1 minus 2. This will become minus 1 plus K cap 2 plus 1. So we have obtained the vector as this is minus 1, this is 2, this is 3. So this is the B cross C value. Now we have to perform the dot product with A vector. So the A vector is given as 1, 1 and 1. So 1, 1 and 1 dot product with minus 1, 2 and 3. So the answer is, we have to multiply it simultaneously. 1 multiply by minus 1, then 1 multiply by 2, then 1 multiplied by 3. So it will be minus 1 plus 2 plus 3. So we can say that we have obtained the volume of this parallelopiped as 4 cubic unit. Now we will try to find out this volume again with box product, means finding the determinant directly. So we will have to use the determinant expansion method to find out the volume, and if we got the same answer, then we can be assured that our both methods are correct. Now to find the volume by the box product method, so we can take A, B, C box product. So this is the determinant 1 1 1 1 minus 1 1 1 2 minus 1. So if we will expand this determinant by the first row, so this will become minus 1 1 2 minus 1, then minus 1, and we will just leave first row and second column, so it will become 1 1 1 and minus 1, then 1 multiplied by, we will eliminate the first row and third column, so it will become 1 minus 1 1 and 2. So if we will solve this, what we will get? 1 multiplied by 1 minus 2, then minus 1 multiplied by minus 1 minus 1 plus 1 multiplied by 2 plus 1. So if we will solve this, what we will get? We will get minus 1, this will become 2, this will become 3. So again we got the answer as 4 cubic unit. So by both the methods we have got the same answer. So this is how we have solved the first example. Now let's move to second example. So in the second example, the adjacent as-is vectors are given. This is A, this is B, and this is C, and the volume is given, and here a variable m is given in the first vector. So we have to find the value of m, so that the volume of this parallelopiped is 48 cubic unit. So we will write the vectors here. So this is minus 2 m. If we will write the b vector as, this is 2 0 minus 2, and we vector write the c vector as minus 5 1 h 0. So this is given in question. So to find the volume, we will use the box product technique. So we will write this as minus 2 m. This is 2 0 minus 2. This is 5 1 minus 5 1 0, and we will expand this determinant with respect to the first row. So we will write here minus 2 multiplied by 0 minus 2 1 0, then minus of minus 2. So we will get it 2 minus 2 minus 5 0. This is m multiplied by, so we will eliminate first row and third column, so it will become 2 0 minus 5 and 1. So if we will solve this, and the value is given as 48 cubic unit, and we have to find the magnitude, because volume is always positive, so we have to consider the magnitude. So this is the most important thing, that we have to consider magnitude. So magnitude of this will become minus 2 multiplied by 0 plus 2. So it minus minus, it will become plus. So 2 multiplied by 0 minus 10 plus m multiplied by 2. 2 minus 0, so it will become 2. We can write this as 2 minus 0, and we have to take the magnitude is equal to 48. So if we will solve this, so it is magnitude of minus 4 minus 20 plus 2m is equal to 48. So if we will further solve this, so what we will get? We will get magnitude of 2m minus 24 is equal to 48. Now here the inequality part comes. So suppose if mod A is equal to 2, then we can write A is plus minus 2. So here with this concept we will solve our equation to find the value of m. So if we will remove the modulus from here, so we will get the two cases. So 2m minus 24 is equal to plus minus 48. So if we will consider the first case, so 2m minus 24 is equal to 48, then 2m is equal to 72. So m value is 36. So the first value is 36, and if 2m minus 24 is equal to minus 48, So 2m is equal to, so this will become minus 24. So m value is minus 12. So we have got the two value of m. So m value can be minus 12 and 36. So if we put any of the value, either minus 12 or 36, we will get the volume as 48 cubic units. So this is how we have solved this question. So this is of different concept. Here the already volume is given and we have to find the value of m. But we will apply the similar formula everywhere where the volume of parallelopiped is asked. So this is how we are done with this video. I hope you like the concept. I have also designed a calculator based on this concept. So I will provide the link of that in the description below. And if you have any other further doubt, then my website link is also given in the description. You can go and register yourself and ask any doubt. You will get connected to the tutor within seconds. So thank you very much.